A lot of people are turned off from designing circuits because it can require a bit of math. And while many engineering equations could easily turn off newcomers, probably the most useful one is thankfully quite simple. It looks a little bit, in fact, it looks exactly like this. And it's called Ohm's law. Ohm's law defines an important relationship between three very important electrical properties: voltage, current, and resistance. And just in case you're wondering, current uses an I instead of a C because C is used for coulombs, which are a unit of electrical charge. But we won't get into that right now. Anyway, you've likely heard the terms used before, but just to get things straight, let's go over what they are. Voltage is defined as a difference in electrical potential. You can imagine it kind of like this. If we have 2 points at different heights, water at one point and water at another point, if we connected those two with a pipe, water would flow from the higher point to the lower. This difference in height between points A and points B is kind of like a voltage. So, when we talk about a 9-volt power supply, we're really talking about 9 volts difference between the supply's positive and negative terminals. And of course, voltage is measured in volts. Make sense? Current refers to the rate at which electrons flow through a given point. And current is measured in amperes. And finally, resistance measures an object's opposition to the flow of electricity. It's a bit like a narrowing in our pipe that would cause a change in current. So, like I said before, Ohm's law defines how those three properties relate to one another. Now, to remember this relationship, we can use this pyramid diagram. To find voltage, we multiply current by resistance. To find current, we divide voltage by resistance. And likewise, to find resistance, we divide voltage by current. As long as we know 2 of the 3 values, we can rearrange this equation to find the third value, thanks to algebra. Let's say I have a 9-volt battery, which I do. So, voltage is 9 volts. I want to limit the current in my circuit to 30 milliamps. And that would be 0.03 amps. I need to figure out what value resistor to use to limit the current to that amount. Ohm's law tells us that resistance equals voltage divided by current. The resistance is equal to 9 divided by 0.03. Therefore, resistance equals 300 ohms. So a 300 ohm resistor. Equipped with Ohm's law, there's nothing you can't handle. Alright, there'll be a few things, especially outside of like circuitry. It's helpful, definitely, to have around. Use it.
Ohm's law is one of the most basic principles in electronics, yet it is not an actual physical law. Understanding Ohm's law is critical to understanding how electric circuits work. Understanding why it is not an actual physical law is critical to understanding the basic principles of logic and the nature of physical laws. Suppose we have a battery and a device which we call a resistor. The battery will create a voltage, causing charged particles to flow around the loop. On the other hand, the resistor tries to prevent the charged particles from flowing. The number of charged particles that pass by each second is what we refer to as the current. There are 3 ways to increase the current. The first way to increase the current is to use more batteries to create a larger voltage. The second way to increase the current is to use a resistor with a smaller resistance. The third way to increase the current is to use several resistors in parallel. Having several resistors in parallel is the same as having one resistor with a much smaller resistance. On the other hand, having several resistors in series is the same thing as having one resistor with a much larger resistance. Let us create a precise mathematical definition for the word resistance. Suppose we take the voltage across the resistor and divide it by the current passing through it. The result of this division is what we will define as the resistance. This is what we refer to as Ohm's law. However, this is not really a physical law, but simply the arbitrary definition that we created for the word resistance. Physical laws tell us how the universe works. Ohm's law would tell us how the universe works if, for example, the value for the resistance of a material always stayed constant. However, this is not the case. As current passes through a material, the material heats up. As a material's temperature changes, its resistance also changes. With most resistors, this effect is relatively small. In the case of some resistors, this effect can be very large. If this effect is large, we can use it to our advantage by using the resistor as a temperature sensor. By placing a voltage with a known value across the resistor and measuring the current that passes through it, we can calculate the resistance of the resistor. This would give us information about the resistor's temperature, and therefore also give us information about the temperature of the material that the resistor is in contact with. Temperature is just one of the many factors that can cause the resistance of a material to change. However, when we say that the resistance changes, all this means is that if we take the voltage across a resistor and divide it by the current passing through the resistor, we will not necessarily always get the same number. The fact that the number that we get at any given time is always equal to the resistance of the material is simply due to the fact that this is how we defined the word resistance in the first place. There are many examples in logic where a statement is always true simply because of the way in which we created our definitions for the words. And the statement doesn't actually tell us anything about the external world around us. This is one of the logical fallacies we need to watch out for, both with regards to science and also with regards to life in general.